Hi, I'm Phil, and today I'm going to talk about the Raspberry Pi 400. I've had it for a couple of days now, enough time to explore to see what it can do, but let's just have a quick look at its capability. So what it is, it's a Raspberry Pi in a keyboard, and to be more specific, it's the Raspberry Pi 4, and it saves you connecting all the cables, and it's a fantastic asset for a STEM educator because it saves time. So every minute counts, particularly if you want to not rush at the end of your session. Projects can be completed fairly quickly with the Raspberry Pi 400. And it's nice that the operating system is preloaded on the SD card, but you only get a 16 gigabyte SD card. So I'd recommend that you upgrade that. And the one that I'm going to show you today, I've upgraded that to 128 gigabytes. So I got it at a good price. And while I can't buy it on many sites, such as Seeed Studio, I could get it on Core Electronics in Australia at a discounted price, which was fantastic. So it's actually quite good value. In applications for STEM education, you can do all the projects, software projects that you would normally do on a Raspberry Pi. And you can also access the 40-pin GPIO header. It does have some limitations, particularly on access, but we'll have a look at that at the moment. And you can use it as a personal computer because you've got the keyboard, the programs, you've got everything you need. So some of the overall features, it's got a 1.8 gigahertz quad core CPU, and it's slightly faster in operations compared to the Raspberry Pi. 4 gigabytes of RAM give you plenty to work on. And for comms, you've got USB and Ethernet. Good display, and you can power it with a USB-C. So let's just have a look at the hardware and some of the things to look out for. We're just opening up our hardware map on the Raspberry Pi, and you can see where the connections are. So it all happens on the back, and it's all hidden to you. So starting off from the left, you've got the 40-pin GPIO header, and you've got the USB power and the Ethernet port on the right. And speed-wise, we'll have a look at that in a minute. So speed-wise, you can see that the Raspberry Pi 400 right on the bottom has slightly better performance compared to the Compute Module 4, which is in the rear terminal, and also it's better than the Raspberry Pi. The only thing to look out for is that the actual pins are upside down. So you have to be a bit careful of that. So when you turn the keyboard upside down, you've got pin 0 and 1 on the left, and on the right, you've got pin 40. And you can compensate for this by getting a converter, which allows you to use it in the normal way, so that special hats that need access from the top can be accessed properly without having to turn around. So this particular one from waveShare, I'd recommend, and I purchased one of these, but I haven't got it yet. In the meantime, I'm struggling with angle converters and extenders, and I'll show you that later on. Now, the project I've been working on to get an idea of what it looks like, we'll have a look at those. And the nice thing about the software is that all the recommended software is already preloaded, and that just saves you a lot of time. So some of the projects I've been working on, I've done the commissioning. I've backed up the OS to 128 gigabyte. A little bit disappointed that I couldn't get the Grove hat, the mini hat, working. And I wanted to see if I could get the mini farm project working on that. But I'll come back to that later. But the one I have been working on is the reSpeaker and also the webcam. Now, before we do that, we might actually look at the critique of the Raspberry Pi 400. And the good points are that it's great for transport. If you have to go to from one site to the other, you've got everything in the one keyboard. It's a good design, well finished, and it's preloaded with the software. The ports are all engraved on the case, including the GPIO numbers. That's great, minimizes error. And overall, it saves time. There's just less to connect. I guess the bad points are, and they're probably not really bad points, they're just things that you can overcome. There's no camera connection. And I'm going to have a look at that in a minute and use a webcam as an alternative. There's no audio as you get with the Raspberry Pi 4. There's no microphone and there's no speaker. And again, we're going to have a look at a couple of projects to compensate for that. And it may be a little bit confusing with the GPIO header orientation, but you get used to that. So the projects I've been working on are to try and compensate for some of those problems. And the one we're going to look at is reSpeaker 2. And just to show you what that looks like, I'll show you a live video of this in a minute. But what I've done here is to connect the Seeed Studio. So on the bottom photo, so here we've got the reSpeaker, and this particular version is the 2 microphones. So you've got a microphone on the right and the left of the hat, and the hat is correctly orientated so we can see the LEDs on top. And I've had to use an angle and a extended header, but even so, I'm occupying valuable space on the keyboard. Luckily, I don't use these keys, and the waveShare GPIO header will provide the correct positioning for this reSpeaker hat. And what's nice about the hat, it provides audio out with a jack, an audio jack, but I've connected it to a speaker. So we've got the Seeed Studio 2-watt speaker connected. And you can also connect to a GPIO using the Grove cables. So I've got the dual push button, and that gives me access to GPIO 12 and 13. And I've also got access to the I2C port. And connected to that, I've got a BME280. And we'll have a look at how that works in a minute. So what's nice about this is that not only does this give you 2 microphones, and all the normal audio software for Raspberry Pi will work with these microphones, it also gives you a speaker, a compact speaker. And that can be quite useful. So the objectives of this project are to test the demos that came with reSpeaker, and I'll do a separate video on the AI voice recognition on that. I wanted to confirm that the 2-microphone reSpeaker actually works, and I wanted to demo everything with Node RED. So just looking at the hardware, you can see I've tested it with a number of devices. So we've got the Raspberry Pi 400, the reSpeaker. For Grove, I've got the Grove Speaker Plus, and I'm using the speaker on that with its JST2 speaker out cable. I'm using the Grove dual buttons, and I'm testing both the BME280 and the BME680, and also the SHT31. And they're all modules available on Node RED for all of those devices. We might actually have a quick look at the nodes that I'm using. So I'm using for demonstration, text to speech, and I'm using the EXE with Python 3 and aPlay as nodes in Node RED, together with GPIO. So if you want to get the push button, it's on GPIO 17, and so in addition to the Grove push buttons, I've also got the reSpeaker push button. And we might actually have a quick look at the program now and give it a bit of a demonstration. So we'll go to here we go. So the overall program, I'll just clear. So this is Node RED, and I've added the extra nodes. So if I press the keyboard on the Raspberry Pi 400, you'll notice on the right that I'm getting acknowledgement that it's been accepted. Or if I press the mouse keys, so I'm running down these flows and just to see how they work. And if I press the push button, I'll just clear those. If I press the push button, I get acknowledgement when it's down and when it's back up again. And if I want to get the temperature, humidity, and pressure, I just press that. And I've got temperature, humidity, and pressure all coming into Node RED, and they're using the BME280. And here's an example of the text to speech.
Hello, I am Philip.
So there's another little demo you can put on. And the other ones are quite interesting. These are actually using a recording. So I can record my voice and play it back. So there's the, if I want to play it back, I'll play it back in a minute. But before I do that, we'll have a look at the LED demo. If I press that, you get a demonstration of the LEDs on reSpeaker. And right on the bottom, we'll just play one of these, and it uses the aPlay node. So if I press that.
This is the Raspberry Pi 400, and it's using the reSpeaker 2-mic array.
Okay, so we might just have a look at the references, and you can get the reSpeaker 2-mic hat for Raspberry Pi from Seeed Studio. And there's quite a few demonstrations, and there's a wiki available. It's quite a reasonable price. The only downside is you get plenty of support for GPIO, and the I2C Grove ports will work. But the examples that are given for the LED array are far too complicated. And I need to put a lot more work in just to make it much simpler. Okay, so stay tuned and I'll give you a video. This is the Raspberry Pi 400, and it's equivalent to a Raspberry Pi 4 inside a keyboard. And it's quite a compact unit with all the connections on the back. And I got the kit with the mouse, the power supply, and a HDMI cable. So with the supplied micro SD card with preloaded software, you're ready to go. And to compensate for a couple of features which are lacking compared to an ordinary Raspberry Pi 4, I've added a audio, and to do that I'm using the Seeed Studio reSpeaker 2-mic hat. So there's a mic on the left and there's a mic on the right, and it not only provides a audio in but also audio out. There's a jack and also a JS2 pin which I've connected to a speaker over here. So this is a speaker from one of the Grove units. And what's nice about the card, that it also has 2 Grove sockets. There's a GPIO, and that goes to GPIO 12 and 13, and also an I2C port. So I've connected over here BME280, and it's measuring temperature, humidity and pressure, and I'm using the dual buttons to go into the GPIO port. So quite a nice arrangement. And the webcam over here is displaying my photo on 2 displays on the PC using VNC, and also to a HDMI monitor over here. And that's one of the connections. On the right we've got the HDMI using a mini HDMI connector. There's the power that's connected, and next to that we've got the camera, the webcam, and there's a micro SD card inside a USB connector, the mouse, and Ethernet connection. So we might actually have a look at one of the displays. We'll go over to the PC and have a look at one of the programs. So we'll just go over to VNC. Here we go. We've got the Node-RED program, and we'll just demonstrate a couple of things on it. So we'll demonstrate a couple of things on Node-RED. So we'll just clear the area over here, and when I press the keyboard, I'm getting messages, debug messages, on my Node-RED debug panel. Similarly with the mouse, I get the mouse movements, and if I press the push button on the reSpeaker, I can also use that in my Node-RED programs. So I'll clear all that, and we'll just see the demonstration of the BME. So if I press this button, I'll get messages of temperature, humidity and pressure. So that allows me to use I2C ports. I've also got a demonstration of text-to-speech.
Hello, I am Philip.
And on the reSpeaker, to demonstrate the use of the pixels, I'm just press this button, and we can just see the LEDs operating. And finally, we'll have a look at the output display. So the audio output goes to the speaker.
This is the Raspberry Pi 400, and it's using the reSpeaker 2-mic array.
Okay, so that's a demo of the Raspberry Pi 400.